So, in the last series, we've been learning about meetup problems when two people, right, are at two ends of, say, a road and they're coming towards each other. So, in this video, in the rest of the series, we will be looking at something that also uses distance, rate, and time, but just maybe in a different direction. That's called catch-up problems. So, first, what are catch-up problems? Well, you can hear it just from its name, catch-up problems, right? It's like two people, and instead of coming in the different directions towards each other, they are going the same direction. And often, when one person is trying to catch up or try to um, or try to like or try to get to another person that's also moving, that's how they have to catch up to each other. So in this video, we'll be exploring the equation that will be used in the rest of these problems. So let's get started. Over here, I have a sketch. So this part is the distance we're looking at right here. And you see there are two people, X and Y. Seems like Y has a head start of this much, and its speed is 3 meters per second, while X has a speed of 5 meters per second. And this whole time, it took 10 seconds for them to go. So what this also means is that it took X 10 seconds to catch up to Y right here at the same place. So let's get started. First, I want to ask you, if we're trying to find this part right here, how can we find that? Well, this is distance, and if you observe the sketch carefully, it's really just this distance ran by y subtracted from the total distance ran by x. So what is the distance ran by x? Well, that would be its speed, 5 meters per second, times the 10 seconds, right? Times 10. And we would minus the amount that y ran, which would be 3 meters per second times 10 seconds. So this would be the distance that y had a head start with. So before going, I want to see how we can really simplify this. Well, I see a 10 and a 10 in each of these, so that means I can factor it out using the distributive property, and that I'll be left with the difference of 5, and that's a minus sign right there, so 5 minus 3. And that equals the amount that y has a head start with. So head start, but in this type of problems, its key term would be difference in track, right? So track is just how much something goes, and this is also their difference of how much each person goes. This is the difference of x's amount that he ran and y's amount that he ran. So this is the formula. Well, this is just numbers, but how can we really turn this into a formula that could be used for any type of catch-up problem? Well, as you may have noticed, what is this 10? Where do we get this 10 from? This 10 is this time right here. So 10 is the time. Now, this is the speed, but not just any speed, but their difference in speed. So their difference in speed. So 5 is x's speed, while 3 is y speed. So this is their difference in speed. So their time times their difference in speed is equal to the difference in track. So please take a moment to memorize that equation. Yeah, this isn't that different from our meter problems. Meter problems just be the time times their sum in their speed. This is just difference in speed, so not that different. Yeah, and this is the main formula we'll be using throughout this series, and see you in problem 1.